Hey guys, Dr. Cooler here. Let's talk real quick about simplifying exponents. So first of all, if we look here, we have 4 times 4 to the 5th power. Now, quick reminder, if you have a number or a letter like a variable or really any base, it technically has an exponent of 1. So what this is saying is that we have 1 4 here being multiplied with 5 more 4s being multiplied here. So when our bases are separate, 4 and 4, that means we can go ahead and add those exponents. So when we add those, we end up with 4 to the 6th power. All right, let's apply that again real quick. Down here below, again, our bases are separate, so we can go ahead and add our exponents. Even though that one's negative, that's okay. All right, so our base is still going to stay 3. And when we add those exponents, -1 plus 3 gives us 2. So we have 3 to the 2nd power. All right. Now, what's different is when you have a base with a power to a power. All right. So when you have a power to a power, like an exponent to an exponent, we are going to multiply those. All right. And same thing. It's okay if you have a negative number. So my base is going to stay 2. That does not change. But my new exponent is going to be -1 times 2, which is going to be -2. So see how we just multiplied those? All right, let's try it again down here. Again, my base stays the same, but I am multiplying my exponents because it's what's called a power to a power, or an exponent to an exponent, okay? So when I multiply those to get my new exponent, -4 times 0 is 0. Now, if you're thinking, wait a minute, there's something special about a 0 exponent. What that means is anytime you have a number or a base to a 0 exponent, it's equal to 1. All right, so don't forget that. Anything to the 0 power equals 1. Now, let's go ahead and look at the last 2 problems we have here. When you have what looks like a fraction, it's actually a division problem, okay? Like before, if you just have a number with no exponent, technically it has an exponent of 1. And when it looks like a fraction like this and our bases match, like the 3 and the 3, we are going to subtract our exponents, okay? So my base is going to stay 3, but when I subtract those exponents, I have 5 minus 1, and my new exponent will be 4. So let's try that again on the last one here. Same thing. My bases match. I have an M and an M, which makes my base stay at M. And then we are going to subtract. When we subtract these exponents, we always do top minus bottom, even if it gives you a negative answer. Okay? But in this case, we're going to do 8 minus 3, which gives us a new exponent of 5. So if you have any more questions as you go over this, let me know.